Hello, this is an introductory talk to NeoFS, the distributed decentralized object storage integrated with the Neo blockchain. We will cover the very basics of how NeoFS works from the user's perspective and what's required to use it. In the following talks, we will dive deeper into the details of the implementation, explain the NeoFS internals, and review different NeoFS use cases for the distributed applications development. In the same way as Neo blockchain network is formed by many nodes in the internet, NeoFS network consists of many NeoFS nodes that are able to store users' data and talk NeoFS API protocol to manipulate that data. This is Alice, and this is Bob. Alice has a picture of a hilarious cat that she wants to store in the internet reliably and share it with Bob. It's stored on her computer in a file named cat.jpg. However, NeoFS is the object storage. It means you cannot just copy a file there. You have to create an object with the contents of that file. Object consists of a data payload and a set of the attributes for the data. Attributes are key-value pairs with information required for NeoFS to work with the data or some user-defined information. For example, each object must have its own unique ID. It's just like a globally unique file name. Also, the system has to know who owns that file and the data payload size. As attributes may hold user-defined information, Alice decided to add a file name of the source file there. Now, let's help Alice to put her cat into NeoFS. Unfortunately, Alice won't be able to store her object for free. She will need to pay a fee for the storage. The price should not be very high, but not for free anyways. Because NeoFS is integrated with Neo blockchain, at first Alice has to deposit some amount of gas to the NeoFS smart contracts address in Neo blockchain. There are some special nodes in NeoFS that support the functioning of the whole NeoFS network, monitor other nodes' health, and ensure that users' data is available and not damaged. Those nodes are called inner ring, and the ordinary nodes are called the outer ring. There are not many of nodes in the inner ring, and all of them are listed in Neo blockchain. They maintain a consistent state of the NeoFS internal structures using DBFT consensus. Inner ring will notice that Alice issued a transaction with a deposit for NeoFS and will create a new account for Alice. Now NeoFS knows about her Neo wallet address and her public key. Alice will sign her request to NeoFS using her wallet's key, and those requests will be verified. For communication with the external world and between nodes, NeoFS uses gRPC-based API. But Alice is a mere mortal human, so for the human's convenience, there is a CLI tool. It will allow Alice to enter simple CLI commands that will be translated into gRPC API calls. One does not simply put an object into NeoFS. If all objects were put into a common heap, it would be a terrible mess. Just like files on the local desktop are organized in directories, objects in NeoFS are organized in containers. Container holds one or more objects. It has unique container ID, owner, and a storage policy description. Storage policy describes rules which must be followed by the NeoFS network when storing object for the particular container. For example, storage policy may define the number of replicas, type of storage device, or the list of geographical regions where to store or not to store the data. In our case, Alice decided to store this container's object in 3 copies in the different nodes anywhere. Now Alice, using NeoFS CLI, creates her container. Information about the new container will be processed by inner ring nodes and made available to all NeoFS nodes. When done, inner ring nodes will deduct a small container creation fee from Alice's account. They use consensus algorithm to propagate those account balance changes consistently. Now the storage policy of storing data in 3 different replicas, as defined by Alice, will be applied for all objects put in this container. But how will it happen? Now we have a container, we can put a cat there. Alice calls NeoFS CLI with put command, passing container's ID and a cat picture object as arguments. Storage policy declares there will be 3 replicas on different nodes, but where exactly will they be? Inner ring nodes constantly monitors other NeoFS storage nodes and maintain a network map. It's a structure that has all NeoFS storage nodes currently available, their parameters and status. When the one wants to put or get an object, a special placement function is called. It will apply storage policy to the network map and calculate the list of nodes responsible for the container. Now, when it knows the list of nodes for the container and object ID, it can calculate the list of nodes that would host that object. This list is sorted by probability of finding an object on that node. So, when we put an object, we firstly pick the node with the highest probability. It will be the first node in that list. Taking 3 nodes, we will know where to put our 3 cats replicas. Now CLI sends the new object to the designated nodes. They will check if this object should be handled by them and take care of replication and execution of storage policy. By now, Alice successfully put her hilarious cat object into NeoFS and is ready to share it with Bob. Let's see how Bob would get it. To let Bob retrieve the cat, Alice sends him a letter with the cat's address. Object address consists of a container ID and object ID. To find object by address, Bob uses NeoFS CLI and issues GET request with the address from Alice. During GET operation, in the exactly same way as was done when Alice issued her put request, the placement function is called. It takes current network map, container storage policy and object ID and calculates the list of nodes that may host the requested object, sorted by probability of finding the object there. Now, knowing where to search for the cat, Bob's request goes to the correct nodes and returns Alice's cat object. Bob is happy to see such a hilarious cat.